Hello everybody. Today we are trying to do an experiment on temperature measurement. Here we're doing it in engineering point of view. However, when someone is sick and go to the hospital, even the doctor, the first thing they do is to try to get the temperature to know what the temperature of the body. However, at the hospital they use a thermometer, but us as engineers, we have some instrument we use to measure the temperature. You guys know that as engineers we can use a thermocouple, which is made of two dissimilar metal joined at one end, only joined at one end, that we call the Horn junction, and the measuring end is called junction. Okay, we can also use an RTD. That's your RTD. A thermocouple sometimes also can look like an RTD. Okay, resistant temperature detector. But the difference is that the RTD is just acts as a resistor. It's a resistor. It has no polarity. While if this was a thermocouple, you'll see that you have to have a polarity, plus, minus. So we can also use an RTD to measure the temperature. Also, as engineers, we can use a thermistor. The thermistor is the one is located inside the kettle. In there, you have a thermistor. Today also we have some ICs such as LM35. It's also a temperature sensor, and there are many the market. But for our purpose here, we will try to demonstrate how can we use a thermocouple or an RTD to measure the temperature. The experiment is known as telemetry. Telemetry normally it's where we deal with communications, so we try to communicate with a real plant by getting the standard signals, which can be current or voltage or pressure. Okay? If it's current, the standard signal we use for current is 4 to 20 milliamps. And for voltage, we use 1 to 5 volts. And for pressure, we use 20 to 100 kilopascal. Okay? For me to measure the temperature of the water in that kettle using an RTD, what I need, number one, I need a 24 volt power supply. Number two, I will need a transmitter. I have a transmitter there, your transmitter. I also need some cables that will connect the power supply to the transmitter. Then I will need a multimeter for display purpose. Remember here the output will be current, so I'll need to display that current. Then I will need also a flat screw drive. The purpose will be to adjust the transmitter, because on the transmitter we have a span and a 0. Then I will need my instrument or the sensor, the RTD. So again, I forgot, we also need that small resistor, 250 ohm resistor. Why I need the resistor? Remember the output is 4 to 20 milliamps, and if I want to convert that output into voltage, so I can use the 250 ohm resistor, or I can use a signal converter. You as students, you need to know how to set up the arrangement. The whole arrangement we have to power, and we use an application known as loop powered. Okay? So the measuring instrument will be in series with the supply, the power supply. Then step number one, this is my 24 power supply. And I check it if it's working. switch it on. See that it's coming on. And the voltage, I have to adjust that voltage. See, take it to 24, somewhere there. This is 24 volt. I'm happy. Then let me first switch it off. Next, I'll check the cable coming from the power supply. I need to connect my transmitter. The transmitter has two sides. See, it's the power side and the signal side. The power side, as you see, it has a V plus and V. You can't see properly. You see, supply. There's V plus, positive, and V negative. So you check the positive lead from your power supply need to be connected to V plus on the transmitter, connect the wire. Then the negative side need to be connected to the negative side of the transmitter, or V minus. Okay, I'll do that. Connect the negative side, the positive side as well. Then on the other side of the transmitter is your signal output. So what we do, I purposely skipped the multimeter first. We connect the multimeter, the last one. Then on the other side, I'll take my RTD. This is the RTD as the transmitter. You have to read carefully. See that you are not swapping the signal side and the power side. Then, because in RTD there is no polarity, I can put the leads at any of the pin there. But this is a 2 wires, and also in some installation we have a 3 wires transmitter. This is easy to install. So I have to put one pin there, one lead, and the other lead on the other side. Okay, let me do it quickly. That's it, done. As you can see that we needed a power supply. There's a power supply, 24 volt power supply is working. Can on it, it's coming on. Then we needed 2 wires. Those are the wires coming to the transmitter. On the transmitter, you have to read carefully that must carefully see the indication that there is supply voltage plus and minus. Make sure the positive lead goes on V plus and the negative lead must go on the V negative. Then this is the output from the transmitter that goes to the sensor or your RTD. Here we have no polarity. You can put any of the lead at any pin. Then that one goes to your RTD, which is this one there. Okay. Now we have to understand that the output from this circuit is current. And how do we measure current? To measure current, we need to connect our multimeter in series. So on the power side, I can disconnect any of the line. Doesn't matter which one I disconnect, and plug in my multimeter in series for me to be able to measure current. Let us do that. I'll take the positive line. Then remember the signal you are taking is coming from the sensor. So when you connect your multimeter, make sure that the red lead or the positive lead must be from the sensor side, and the negative one need to go to the power supply. Let us do it quickly. Okay, there we go. So what I did, I connected on the power side the multimeter in series. So as you see, the signal from the transmitter goes to the positive lead of the multimeter. Then from the multimeter to the negative lead, this is the one, goes back to the power supply. Then the multimeter needs to be set up on current. See that it's off. Put on milliamps. The maximum looking is 20 milliamps. You can put it at 200 milliamps. Okay. At the moment, it's showing 0 milliamps. Why? Because your power supply is off. Sometimes they can ask you a question, what happens if there's power failure? Don't tell me that there will be incorrect result. The answer must be there will be no feedback, there will be no signal at all. So it's 0 milliamps. How a loop powered circuit is connected, power supply, multimeter in series, transmitter, then your RTD. Now I have to power on the supply and check the multimeter. There is a reading. I think it's the lead. I don't know, we have to swap the lead. So the positive line need to come from the power supply. So the correct way is to take the positive lead of the multimeter straight to the power supply. So as I switch on the power supply, I'm reading a value which is 3.8 milliamps. But with this instrument, in reality, I need to see 4 milliamps. That's why I said you need a screwdriver. So if you're reading 3.8 milliamps, what you need to do is to come here on the transmitter and adjust the 0. There's a small screw there. You have to adjust it. You'll bring the voltage to 4. Okay, adjust your 0. You see, I'm adjusting the 0. Then I'm getting 4 milliamps. 4 milliamps mean the minimum temperature. Okay, now I will put the RTD in boiling water, and you'll see that the temperature or the current from the multimeter will be increasing proportional to the temperature in the kettle. Let us do it. Now what I'm going to do, I'll take the RTD, put it in the kettle, and switch on the kettle, boil the water. Okay, waiting for the water to boil. The water starts warming or heating, then you can observe how the output current is increasing on the multimeter. Can you see? It's going up. The maximum current you can expect here will be 20 milliamps. 20 milliamps means that the temperature of the water in the kettle have reached the maximum, which will be 100 degrees Celsius. So when it reaches 100 degrees Celsius on the inside the kettle, temperature of water, the output current will be 20 milliamps. It's linear. Okay, as you see there, the current is increasing because the water is boiling. So in another way, this is how you have to understand it. So as engineers will be dealing with a current output signal. How do we interpret that? This is the temperature range. Let's assume that the temperature was starting from 24 degrees, and when the water starts boiling, that will be 100 degrees Celsius. You see that at 24, the current output was 4. So when it reaches 100 degrees, our current output will be 20 milliamps. And any current in between 4 and 20 will be related to a temperature, given temperature. So that's how we know what is the temperature in any process according to the current we're getting on the multimeter. So this is how we measure temperature using an RTD with a loop powered system. Loop powered means that we have a power supply, transmitter, then there's your instrument, the sensor, then the measuring instrument, which is the multimeter, is connected in series with the power source or power supply. I'm sure you guys can be able to interpret and do the same thing. Thank you. Goodbye. I think my time is finishing. Otherwise, as you see there, the temperature is still increasing. It will increase until 20 milliamps. Thank you. Bonne chance à tous. Bye bye.